You're not too far behind, don't worry. I've written nothing. All right, guys, so we're going to practice the domain a little bit more with some trickier ones. And I want you to use interval notation. Do you guys know what I mean when I say interval notation? Yeah. Yeah? Okay, like parentheses, brackets, that stuff. Yeah. Okay. Let's do f of x equals square root of negative 2x plus 3. Give you some different ones here, guys. Some rationals, some radicals. Kind of a long warm-up today. I'll go back up to the top here in just a minute for you, okay? And then we're also going to talk just a little bit about even, odd, or neither, okay? I'll go back up, guys, too. Sorry. Let me just get it all written. Okay, guys, I'm going back up to the top, and then I'll scroll down, and if you didn't get those last two, jot it down. That's okay. We'll get to them. So the first 5 are domain. 4 and 5 are definitely going to be, I think, the trickiest ones for you on here. But I'll give you some time here, and you can talk to each other. That's great. You guys are going to definitely remember different things. We'll see if you remember anything. I don't know. I don't know many Uh-oh. I think we all should. So domain, think about what it can't equal. Like, what can't you take the square root of? Okay. And like the fraction one, what can't you divide by? Okay, think about those as you're going through this. Think about what it can't be, and then you can write your domain from there. Okay? You should do it algebraically, not just like guess and check. I'll give you a nudge on the first one. Okay? So you said you can't take the square root of a negative, right? Okay, so what's under here, this negative 2x plus 3, would need to be greater than or equal to 0. Does that nudge helpful? Okay, perfect. Solve that, write it in interval notation. That's where you're starting. Okay? All right, Matthew, keep working on that math for me. Thanks. Getting there.
Wait, was that right? Since you're negative how much is that? Let's see, because you're 3 over 2. Yeah.
Okay. Yeah, that's why it's up like.
Yeah. Oh, it is 1.5. Yeah. Sorry.
So then I guess you just have a set it up the same way.
But instead of greater than or equal to 0, what would you be?
Oh, greater. Wait.
Just not equal to, right? Because you said you can't divide by 0, so you don't want that to equal to 0. All right. Yeah, if you guys can't read anything, let me know. That is X cubed. It's really tiny. Great. Hey, Jacob, did you ever get all your login stuff to work?
Not really.
Okay. I will fix it for you. I figured out how to do it. So, did any other teacher try to reset for you?
Yeah.
And it still didn't work? Ah.
I talked with the technical yesterday, and they said it's the problem with Schoology, like updating passwords.
That's ridiculous. But, well, you don't really need it today, so it's fine. Or at least in here you don't need it. I don't know about your other classes. Shoot, it worked because I had some other people that was the only thing they couldn't get into, and I reset their password for them, and then they could log in. So.
Oh, yeah, I did that in like history class.
And it didn't work, yeah. You're just extra special.
Oh my God.
Guys, I'm going to scroll down a little just so you can see more of the problems in case you need them. We're obviously going to go through all of these, okay? These 2, 4, and 5 are the tricky ones. You're like, wait, we haven't gotten to the tricky ones yet. It's okay. Yeah. It's all tricky right now.
I'm having to math in so long.
You guys are going to be really excited when we get to like new stuff that has nothing to do with algebra 2. You're going to be like, yeah, fresh start. It's comforting when your neighbor gets the same thing, right?
I know what I'm thinking. Are you asking me or are you telling me?
Yes.
I can't tell. I'm sorry. Someone I'll try to.
Where? Sorry.
What is that an X or
X. Yeah. I didn't throw another variable in. I probably
It's your problem.
We'll come back to you later, right? Give them a shot, and then we'll definitely go through them. Okay? I promise.
So then it's like the answer would be right. I'm gonna try this. I love the first one. And you don't include any of them because it can't be yeah.
You guys want a few more minutes to keep trying the domain ones, or are you ready? A few more minutes? Okay. All right.
And then yeah. And then yeah.
Okay, that wasn't bad. Ella, thank you.
I know it's scary, but no, actually don't. You just do like this. Well, you have to take the answer straight, but I think it's one Oh, well then, you would add the extra one in the middle, that's like, and then
So that's the case, what am
Okay. I am well aware it's going to take a while to get you guys like back in the swing of it, and even like working with speed. You know what I mean? Like it's different. It was very different. So we'll get there. What were you going to say though?
I didn't know before, my sister was in class.
Oh, she was. Yeah.
Yeah.
How's she doing?
She's good, she's trying to get back now.
Okay.
Yeah.
Nice.
I think she likes it, I don't know. She doesn't really talk about it. She talks.
Fairly quiet. So I can see that. Yeah. I think you're sitting on the same desk she sat in too.
Really?
Mhm.
Oh my gosh, I have to tell her that.
Yeah, tell her you got your desk. I have a lot of siblings this year, but I didn't realize right away. I'm like, really? I know that name. I know that's why it's fun. So.
oh, we're just, I tried it, and if it's
That's
wrong,
okay.
There's an answer.
Okay. Guys, let me scroll down just so you can, if you're either good with the domain or you're like, oh my gosh, let me move on to even and odd, that's fine. Let me scroll down so you can see those last two.
Let's try.
Yes. We'll go over all of them, guys. Don't worry, okay? It's all right if these are challenging. Here, I'm moving up a little bit.
That's confusing. Wait a
You did? I feel like you look the fuck. Are you in this project class? No. Just that's
No, you have to prove it by showing what f of negative x is equal to with the even, odd, or neither. The degree, plays into it to some part, but you have to actually prove it by showing f of negative x.
like about the even, odd, or neither. Like, what about if it's even, odd, or neither?
So if a graph is even, it's symmetric to the y-axis, like you could fold it in half along the y-axis. And if a function's odd, it has rotational symmetry, where you could rotate it 180 degrees and it will look the same.
Okay.
But then you can prove it algebraically without graphing. Guys, I'll give you till it's 10:08. I'll give you till about 10:10, and then we'll go through them. It's fine if you're not done. Good question.
When were we supposed to?
Yeah, who is like, oh, I've heard of even, odd, and neither. Yeah, some not so much though.
I'm not even sure.
Okay. And I know, like, the 3 different Algebra 2 honors teachers last year definitely got through different content. Like, they focused on different things. So I know you guys are going to come in where some of you are like, I've seen that, and others are like, what? So we'll go through it. It's okay. So you might be in the nope, didn't see it group. All right, guys, let's go through these. Yes, please. All right. Okay, so starting with domain first. When you're doing domain, you're really thinking about what x can't equal, and then you can write the domain from there. So when it's a square root, like number 1, an even root like that, what's under that even root can't be negative. You guys know you get an imaginary number if you take the square root of a negative. So the process to go through, take whatever's under the radical there and say that has to be greater than or equal to 0. And then you're just solving that inequality. So negative 2x is greater than or equal to negative 3. Divide, remember to flip your sign when you divide by a negative. So we get x has to be less than or equal to 3 halves. So in interval notation, that is negative infinity to 3 halves for the bracket. All right, number 1. Okay? Yeah, okay. So that's sort of one situation.
Do you need one extra?
I think I'm good.
Do you have a vest in there?
Let me double check.
Because the vest is missing.
Oh, I have a vest.
Oh, okay.
Good. Thank you so much. All right, guys. So then the second one here, this is a fraction. This is the other thing you have to worry about. The only 2 things you have to worry about are even roots and denominators of fractions. So we don't really care what's in the numerator because there's not a radical up there. So all we worry about is the denominator cannot equal 0. So then I just solve this. I could factor out an x. I have x squared. Does it seem easier now?
Yeah.
Okay, good.
So scared.
So 0. So x cannot equal 0 or positive or negative 3. So interval notation, that's kind of long to write, but we'll do it. It's negative infinity to negative 3, parenthesis, not a bracket, because you're jumping over the negative 3, and then you're going negative 3 to 0. I'm going to run out of room. 0 to 3, and 3 to infinity. Okay? Sorry. So that's a long one with the interval notation. Does that make sense? Okay? All right. Stop me at any point on these if you're like, no, explain that again. That's why I'm here. Okay. And I know that's hard to read. Sorry. You can visually think about this, you know, it can't equal 0 or positive or negative 3. Like, visualize it on a number line. I'm telling you, it can be everything except for those values. So that's why we have all these sections. Because it can be negative infinity up to negative 3, between negative 3 and 0, between 0 and 3, and from 3 to infinity. Okay? So you don't need the number line to solve this, but that's just a visual of what your answer is saying. All right, ready for 3? Okay, so what you should ask yourself every time, do I have an even root, like an even radical? What do you think on number 3, do I? No, it's odd, right? Okay, so I don't have to worry about that. Do I have a fraction? Yes. So the only thing I have to worry about is this part of the fraction cannot equal 0. Okay, it doesn't matter if it's negative. I can take the cubed root of a negative number, but I can't divide by 0. So I just have to think about that fraction cannot equal 0, that denominator. Then it's just a matter of factoring. X plus 3, x minus 1 can't equal 0. So x cannot equal negative 3 or 1. So my answer would be negative infinity to negative 3 union negative 3 to 1 and 1 to infinity. Yeah. Okay, so cubed root of 8, what is that? 2. Okay, what about cubed root of negative 8? Negative 2, actually. But that's okay, right? Whereas if I had said square root of negative 4, you'd go, ooh, 2i? Okay, can't. So the only even roots cause us trouble, okay? So if it's an odd root, you can just ignore the fact that there's a radical there when you're figuring out the domain. You can think about it graphically too, like very basic here, but square root. Right, that domain is clearly not all real numbers, right? It's just from 0 to infinity. Whereas if I graph the cube root, you see how the domains are very different? Yeah, okay. All right, other questions on the first 3? Now we get to the tricky one. Okay, so number 4, I definitely have an even root. So I have to take what's under the radical, this x cubed minus 2x squared. And that has to be greater than or equal to 0. Okay, it's an inequality, so you can't just go, all right, I'll factor it, and I'll set both of those greater than or equal to 0. Like, nope, you can't do it that way. Okay, that's not the way it works with inequalities. You got to do a little more work. We will still factor in our first step. But then you are going to make a number line and test the regions of your number line. Okay? So I'm going to draw a little number line here. There are 2 values that matter on the number line. Anybody think they know what those 2 values might be? Any guesses?
0 and 2.
Excellent. 0 and 2. Why did you say 0 and 2?
Because factors.
Yeah, those are your 2 factors. What would make each factor 0? Okay. So you factor it first. Setting those factors equal to 0 in your mind, that's where you get the numbers on the number line. All right, so we're okay to that point. What you're going to do next is test the regions of your number line. So I'm going to plug in a 1. Plug in 1. I'm picking 1 because 1 is pretty easy to plug in. You can pick any number you want to plug in except the 0 and the 2, except those 2 values that are already on your number line. Okay, so when I say plug in a 1, what I mean is I'm plugging a 1 in for the x's here. So when I plug a 1 in here, 1 squared, is that positive or negative? Positive, okay. Positive. And then I plug it into the x minus 2, so 1 minus 2, what do you think, positive or negative? Okay. What is a positive times a negative? Negative. Okay, so that region of the number line is negative. Now guys, why did I put it in here and not over here and over here? Exactly. Whatever number I pick to plug in, that's the region of the number line I'm looking at. Okay. So then you can test the other regions. If you remember multiplicity and graphing polynomials, is that ringing a bell? Okay. Oh, yes. You can use that so you can kind of cheat on your number line. But if you don't remember, we'll just test the other regions and then we'll get to the multiplicity piece. So if I plug a negative 1 in, I'm just picking something over here. You can pick negative 72 if you wanted to, but negative 1 because it's easy. What's negative 1 squared? Okay, positive, right? And what about negative 1 minus 2? Okay, so I have a positive times a negative again. So that region is negative. What if I plug a 3 in? What's 3 squared? Okay, so positive. What about 3 minus 2? Positive. Positive times positive is positive. Okay? Written the answer yet, but are we okay with what's going on that number line? Kind of. Okay. If you remember multiplicity, even multiplicity is where your graph would bounce off the x-axis, which means if it's negative on one side, it's going to stay negative on the other side. You can kind of use that to cheat your way through the number line instead of testing every region. If it doesn't have even multiplicity, like this one doesn't, it'll always alternate on either side. You can just test your regions for now, though. That's okay. All right, so the question then asked, when is this greater than or equal to 0? Okay, that means I'm looking for the positive part. So I'm looking for this piece over here from 2 on. Are there any other parts of the number line that are going to matter? Would the 2 be included or not? Okay. What about the 0? I want where it's greater than or equal to 0. What happens at 0? Doesn't it equal 0 there? Yeah, it does. So your answer to this is 0 by itself, and then from 2 to infinity. If you really like graphing polynomials, you can think about it in that aspect as well. I could look at this piece right here, this x squared times x minus 2, and go, okay, I know I have a 0 at 0, 0. I have 1 at 2. I know my end behavior. That's going down. That's going up. Bouncing. There we go. You can graph it if you like graphing. Usually people don't pick that method. But you can see then where is it greater than or equal to 0, meaning when is it on the x-axis or above it, at 0, 0, and from 2 on. Okay, so just another visual of how that domain works. As I said, 4 and 5 were the tricky ones on here.
I don't know about anyone else, but I've never done that.
I believe that. That's okay. We'll practice more of them. Do you have questions? Like, are you like, okay, it makes sense. Not sure I can do it on my own yet, but it makes sense. Okay. Yes. The x cubed minus 2x squared.
Yeah.
I just factored. So I factored an x squared out of both. Yep. And so the only time you have to do this number line, like if you look back to question 1, that had a radical in it and we didn't do the number line. It's because it was a first degree under there. Okay, so it's only if it's second degree or higher under your radical that you have to do this number line stuff. Okay, let's look at 5. We'll get to do things again here in 5. Okay, fraction and radical happening, even radical, so clearly we got to think about a lot of things combined here. I need to make sure what's under this radical is not negative, but also because it's in the denominator of the fraction, it can't equal 0. So I have to take that x squared minus 6x plus 8, and instead of saying greater than or equal to 0, what do you think I'm going to say this time? Right, just greater than. I don't want it to equal 0. It's in the denominator of the fraction. Okay. All right, but it's x squared. So what do I have to do? What should my next step be? Factor, yes. So that's going to factor x minus 4, x minus 2 greater than 0. Okay, factors with that inequality. That means I need a number line. What are the 2 points on my number line? 2 and 4. All right. Let me stop there for a second, make sure you guys are okay. Are you with me? Okay. All right. What would you like to test on your number line? What number seems easy? 3 would work. What else is even easier?
4.
Okay. Maybe even easier than what?
0.
Okay, we could test 0, right? It's not one of the points on the number line. You can pick any of those numbers. That's fine. 0, 1, 3. I'm going to pick 0. Plug in 0. Okay, so 0 minus 4, negative. 0 minus 2, negative. Negative times a negative, positive. Okay. And is everybody okay with why this time I'm putting it on the left end of my number line? Okay, that's where 0, the number I'm plugging in, that's where it would live on my number line. Okay. Again, we can test all of the regions if you would like. Let's talk about multiplicity again. Do either of my factors have multiplicity, like the x minus 4 and the x minus 2? No multiplicity, right? If there's no multiplicity, your number line will alternate. Okay, so once I know this region's positive, I can go, all right, you're negative, you're positive. If that makes you nervous and you don't trust it yet, you can always check them. The degree. So like if it had been x minus 4 quantity squared, that would have multiplicity. Yeah, good question. So in number 4 that we did up here, see how the x was squared? That had multiplicity, and that's why that one like went negative, negative, and then positive. Okay. All right, we're almost done with this one. We want to know, when is it greater than 0? Okay, so that's the outside edges, because that's positive. And what do you think? Are we including the 2 and the 4 this time? No. Good. So those are going to be parentheses. So negative infinity to 2 with a parenthesis, and then parenthesis 4 to infinity. Okay. Questions on domain? feel like a lot for a warm-up? This feels like a test. Oh dear. Okay. We'll get there. All right, guys. Even, odd, or neither. Let's get through these two, and then we'll actually start our notes, okay? Domain, we're going to come back and keep practicing this. You'll see this again in warm-ups, catch-up day, review day. Like, we're not just going to forget about it now. We'll keep revisiting domain, because I know you need more practice on it, okay? All right. Even, odd, or neither. The way you determine this is you plug in a negative x. So what I mean by that, we started with f of x. I'm now going to show what f of negative x is. So that'd be -3, and then in parentheses, negative x, quantity cubed, 2, parentheses, negative x squared, -5, parentheses, negative x. You have to show I'm plugging in a negative x. Okay. And then you show what it simplifies to. So when I cube a negative x, is that going to remain negative or become positive? Negative. And then there's already a -3 times that. So this ends up being 3x cubed. But please be careful with your order of operations. I didn't just do -3 times negative x. Okay? Think of the negative x cubed first, then times -3. All right, so then the next one here, negative x when I square it will become positive, and then times 2, so that's going to be plus 2x squared. And then I've got a -5 times negative x, that would be plus 5x. Okay, so you just have to show what it is simplified. Not that hard, right? Then how you determine your answer. You compare the one you just found with the original. If it is exactly the same, that means it's an even function. Okay, if it's the complete opposite, meaning every single sign has changed, that is odd. And if it's just different, then that's neither. So what do you think on this one, guys?
Neither.
Yep. And guys, this is a course you're starting to get into, the math courses where your notation is really important, and I'm going to be picky about your notation. You have to write out f of negative x equals. Like, you have to show that. You have to show that you plugged in the negative x. If you just kind of do a little bit of simplifying and write neither, you're not going to get full credit. Okay, so you got to show what you're doing. All right, let's do 7. So again, I'm going to show plugging it in. So 3 times negative x, 2 times negative x squared plus 5. And then we simplify. So I've got negative 3x as my numerator. And I've got 2x squared plus 5 as my denominator. We're okay? I see some questioning. I have to like read your eyebrows now. Like, what are... Anybody questions on the simplifying? Okay, even, odd, or neat. Like we got here. Raise your hand if you think it's even. Raise your hand if you think it's odd. Raise your hand if you think it's neither. Okay. Let me remind you of fractions. Let's say I start with the fraction 3/4. What's the opposite of 3/4? Oh, so like the numerator's opposite and the denominator stayed the same, right?
Yeah.
What if they both were opposite? Oh, okay. So fractions, you have to think a little more. So let's go back to it. Let's try again. What do you think it is now? Raise your hand if you think it's even. Odd. Yeah, that is odd. Good. It's trickier with fractions. Does that make sense, though, seeing?
Yeah.
Okay. All right. Questions on the warm-up? You guys are like spent, and we haven't even gotten to the notes yet.
That's just the lesson. What if you just...
Your homework would be a little tricky if I didn't teach you anything else. All right, we okay? I promise we'll keep revisiting, okay? Don't get scared. All right, so wherever you're taking your notes, if you have a notebook, paper, I don't care what you take them on, but you just have to write notes for me. So the first thing we're going to jot down is the intermediate value theorem. It's kind of wordy, so let's get the whole thing written down, and then I'll explain what it means. Okay, so just stick with me as we write it out, and then we'll look at it, and I'll interpret it for you, okay? So we are jotting down the intermediate value theorem. And we'll reference it as the IVT. If f of x is a continuous function, and a is less than b, and there is a value n such that n is between f of a. I told you this was really wordy, right? Okay, just stick with me. I'll explain it. And f of b, then there exists a c such that a is less than c is less than b, and f of c equals n. Perfectly clear, right? You don't need any more explanation. Yeah. Sure. We're feeling real good about today so far, aren't we? I will draw a picture that will help a little bit, okay? but I'll let you write first. Okay, I'll draw you a picture. Okay, so it's just a little graph here. On the x-axis, I'm going to say that is A. B is over here. And remember it said A is less than C is less than B. That means C goes somewhere in between A and B. Okay, it's not necessarily right in the middle, just it's in between A and B. All right, I'm going to draw a little graph for us here too. And it won't always go through the x-axis there for where point C is, but just an example for you. So if I was going to label some points here, that point on the graph would be A, f of A. Does that make sense to you guys? Like, are you okay with that function notation? If the x is A, the y value is f of A. Yeah? Okay. So this point in the middle here would be C, f of C, right? And if I label this guy up here, B, f of B. Okay, it's just another way to write your y values. And in the theorem here, they also talk about f of c equals n. So another way I could write this middle point is c comma n. Okay, so now let me paint all of these words. Okay, so the graph here, this is my f of x function. It's a continuous function. Okay. And a is less than b, so you can see on the x-axis, right? A is less than B. So I've got two values in order. There's a value n such that n is between f of A and f of B. Well, here's f of A down here. Here's f of B up here. Would you agree n is in between those, right? Okay. If that's true, then there has to be a C such that C is in between A and B. F of C and N are the same thing. What you're trying to prove, you usually use this when you're trying to show that a graph equals 0 somewhere in between these two values. So you would know, like, let's say this point is like 3, -2. And this point is 5, 3. If your graph is continuous and it goes from a negative y value to a positive y value, doesn't it have to equal 0 somewhere in between? It's logical. This is the really wordy way to prove that, okay? That's all you're doing is showing like, oh, it went from negative to positive. It must have been 0 in between. And that's what you're going to do with it, okay? All right, let's just try one. Okay, so you might be given f of x equals x squared plus 2x minus 3. You'll be asked something like, does f of x equal 0 on the interval -1 to 3? This is not just a yes kind of answer, okay? It'll usually say justify with the IVT, something like that. So there's a very formulaic way you have to answer questions like this. And I'll walk you through that. So first, we need to know if this is a continuous function. What do you think? X squared plus 2x minus 3? Do you think that's probably continuous? Yeah, that's just a parabola, right? You don't have to graph it or anything. You just need kind of a mental, yeah, that's continuous, okay? We need to know, does it equal 0? Like, we should try to think about this. So I would first, off to the side here, you need to kind of evaluate these endpoints. What is f of -1? So if I plug that in to f of x, what do I get for f of -1?
Plug -1 in, you'll get 0.
Nope.
Wait.
-4.
Lots of answers. One of those was right.
I'm sorry, it's -4.
It is -4, yes. All right. Let's try again. Let's find f of 3. No negatives to plug in this time. It's easier.
12.
12, good. So before we go through the IVT notation, if it goes from -4 to +12, do you think it equals 0 somewhere in there? Yes. Okay, that's the whole point of this. It's just like, oh yeah, I go from negative to positive, I must equal 0. But the way you write your answer matters. So we're going to do it with 5 bullet points. Don't try to oh, I'll write it in a paragraph, or oh, I'll write it in my own words. Just do it the way I show you how to do it. That's okay. So first bullet point, we have to state that f of x is a continuous function. And you can abbreviate. If it's not continuous, then all sorts of weird things could happen. So it's got to be continuous. So you know that an x squared, that's a parabola, right? And the plus 2x minus 3, there's nothing weird happening in there. So you can just know sort of your knowledge about these functions. Sometimes you'll be given the graph or given a table, and you can just see from there, okay. Sometimes they even just tell you f of x is continuous. So you go, okay, I got it. All right, the next step is talking about the y values, and you have to put them in order. So your two options here are f of -1 and f of 3. Ours is nice, f of -1 is the smaller one, f of 3 ends up being the bigger value. Sometimes it'll be switched, sometimes it'll go from a positive value to a negative value. So you have to make sure you write the correct inequalities. So I'm going to say f of -1 is less than 0 is less than f of 3. Okay, don't tell me -4 is less than 0 is less than 12. That's not what I want. I want the function notation of it, okay? And do you guys understand what I mean, how sometimes it might be switched? Okay, so just double check, make sure you put that in order. All right, your third point. So there exists a C, -1 is less than C is less than 3. So we've gone from talking about the Y values to talking about the X values. So this bullet point was Y values, and this one's X values. Okay. All right, fourth one, such that f of C equals 0. And your last one is by the IVT. Super fun, right? All right, now for answering this type of questions. Guys, the first bullet point is never going to change. That is always going to be f of x is a continuous function. Okay? The second bullet point, the only part that will change is the -1 and the 3. That's just based on, you know, the values you're given. It'll be f of something less than 0, less than f of something. The third one, so there exists a C. The -1 and the 3 will change. Otherwise, it'll be the same every single time. Such that f of C equals 0. It's really unlikely that I'll give you any other than 0. So that bullet point will stay, and the last one will absolutely stay by the IVT. So there's really not that. You just have to memorize certain parts of this and understand the format. So again, do 5 bullet points. Don't write me a paragraph. Don't combine things. Just do it exactly like this. Okay? All right. We're going to do, we have extrema and average rate of change left. If we have time after that, we'll come back and practice another one of these. But I want to make sure we get through the terminology with those 2 pieces first, okay? Anybody questions on this before we shift gears slightly? Okay. All right. I am going to draw a graph for you. Just a sketch of a graph. All right, so this first point was -5, -5. This is -1, 2. Clearly, this is not drawn to scale. That's okay. This point is 1, 2. Make that guy 5, 4. All right. We are going to look at where is this constant. What do you think, guys? Well, let me give you another minute. Make sure you've got the graph jotted down. Okay, guys, any thoughts on where this graph is constant? Even though we haven't like formally defined that, do you have a thought on which section of the graph might be constant? Yeah, go ahead.
X equals -1 to 1.
Yes, exactly. This little just horizontal piece in the middle, and the way you write that answer is in interval notation. We would say from -1 to 1. And the reason I'm using parentheses is because at the end point, it's not increasing, decreasing, or constant. Okay, it's it's where it changes from one to the other. So at that point is not doing either. So just know you'll always use parentheses when you're writing these. Okay. All right. Decreasing. What do you think? Where is this graph decreasing? You'll notice for the constant, you gave me x values for the interval. You're going to do that for decreasing, increasing as well. Okay? It's over what x values are the y values decreasing.
-infinity to -5 and 5 to infinity.
Perfect. So -infinity to -5. You always read it from the left to the right. It's going downhill there. Union 5 to infinity. Okay with that? Alright. What about increasing? Yeah, go ahead.
-5 to -1, and 1 to 5.
Perfect. -5 to -1, union 1 to 5. So again, all of those, your answers are the x values. You're talking about the y values as far as increasing, decreasing, but you're telling me that happens over which x values. Okay, we are also going to talk about maxes and minimums. So I want a local maximum here. We'll talk about local, which is the same as relative, and then you can also have an absolute max or min. Local just means somewhere on the graph, it's a point that's higher than any of the other points right around it. It's not the highest point on the entire graph, but if you zoom in on that little window, it's the highest one. And we have a notation way to write this. So anybody think they know the point that is the local max? What do you think? Yeah, go ahead.
5, 4.
Exactly, like top of a hill, okay? That's the maximum. We don't write it as the ordered pair. We say the maximum is 4, and that happens at x equals 5. Okay, so pay attention to that notation. If you write the ordered pair on your test, you would get partial credit. Okay. What about a local minimum? And there can be more than one on certain graphs. If you have multiple maxes and mins, that's fine. There's only one on this one. What do we think for the local min? Yeah, go ahead.
-5 at x equals -5.
Perfect. Okay, so again, pay attention to that notation. All right, so extrema, not too bad. Fairly intuitive, max, min, increasing, decreasing. These are things that I think make sense to you guys, okay? Let me draw one more line on here and see if you remember what it's called from geometry. If I draw a line like that touches the graph in 2 points. Anybody remember what that line is called from geometry? Thoughts? No idea? It's a secant line. Do you guys see secant. We'll talk about slope of a secant line as the year progresses, so I want to make sure you actually know what a secant line is. You remember a tangent line touches your graph at one point. You usually did it with circles. Yeah, the secant line touched your circle in 2 points, tangent just in one. Okay. Geometry was a while ago. All right, any questions on that stuff? Easier than the IVT? I could ask you for absolute, but the only time you have an absolute is if you don't have like the ends of your graphs with arrows. So like, like that has an absolute maximum because both ends are going down. But usually we're going to see polynomials where you're up and down and lots of things are happening, okay? Okay, so the last sort of topic we have for today is average rate of change. Average rate of change is just slope of the secant line. Draw a picture for you. So there's my lovely graph. Draw a secant line. I'll call this first point A, f of A. I'll call the second point over here B, f of B. Take a second to jot that down and then the formula. So guys, back from like algebra 1 even, what is slope? Like how do you find slope? Blanks, that's okay. Anybody?
Rise over run.
Rise over run, okay. And if you were like writing out the formula, what would you write? So yes, the m is slope, but how did you find?
Is it like y2 minus y1 over x2 minus x1?
Yes, exactly. That's the slope formula, right? You guys, that's ingrained in your head somewhere. That's what we're going to do here, but instead of y's and x's, we have these f of a's and b's and all that stuff. So my formula is just going to be f of b minus f of a over b minus a. But do you see how that's, I mean, that's really just slope. It's just written in fancy function notation for you. All right, so the way a question might look, you'll see find the average rate of change from -3 to -1, given the function f of x is equal to -2x squared plus 4x plus 6. Sorry, I'll move it up so you can see it better. So the x values you're given are the -3 and the -1. And then you're given the function. So how could you find the y values that go with those x values? Plug it in. Yeah, just plug them in. So the first thing you're going to do is find what f of -3 is equal to and what f of -1 is equal to. So plug that in, do a little mental math here. Can you figure it out? Be careful with your signs. Or you can write it down if you need to, if your brain's not ready yet. So find f of -3 and f of -1. All right, guys, what'd you get for f of -3? -24 and f of -1? Okay, good. So guys, what this means is you have the ordered pairs -3, -24, and -1, 0. So your average rate of change, which you can abbreviate as AROC, A-R-O-C. Okay, you're just going to do 0 minus -24 over -1 minus -3. What do we get? What's the slope of the secant line? Well, you messed up the sign in there. That's it. It is 12. So you get 24 over 2. So easy to mess up a negative in there. That is your average rate of change. Okay? All right. How we doing, guys? Hanging in there? Is this week feeling long already?
It feels like Friday.
I know, it's only Wednesday, guys. do this. We're gonna save, because we've got about 6 minutes left, 6 or 7 minutes. We're not gonna go do another one of the IVT problems. We will do another one in class next time, probably as a warm-up, just to make sure we're okay with that. So that's the end of your notes. So your homework is on math space. It's been assigned to you. So today's Wednesday, so it's due tomorrow night by 11:59 p.m. Okay. And guys, I know last year you probably got used to like the lessons being recorded when they were virtual. I always do that. I've been doing that before we went virtual. So I just record, you'll see the screen, like whatever's projected on the board, and you'll hear me and sometimes you. But so on Schoology, there will be a folder that has links to every lesson. So if you ever need to review something, or if you're ever absent, you can just watch what happened in class. Okay? So you can use your time and start if you want. You've got 6 minutes, guys.